so now we want to find the derivative of g of 4. So first we're going to find the derivative. I want to convert that because do I have a square root anywhere on my formula sheet? I have to do something to the square root. I have to say that 4 times the square root of t to the 1/2 power. If I have the nth root, because it doesn't have to be a square root, it could be a cube root, it could be any root, right? So there's some root for this one, n is 2 of t to some power, and here our power is 1. That's the same as the nth root of t to the m power. Most of the time, this is equal to t to the m over n. M in our case is 1 because it's t to the 1 inside the square root. And since there's no n outside the radical, it's automatically assumed to be 2. That's how I get t to the 1/2. Now, I'm going to find the derivative. First thing I do is I take the 4 outside of the function, and then I can use the power rule because I have a variable to a constant. This becomes 1/2 t to the 1/2 minus 1. First thing I'm going to do is I'm going to say 4 times 1/2 is 2, because that way I don't have to worry about that whole thing. And then I have t to the 1/2 minus 1, which is negative 1/2, which is the same as 2 divided by the square root of t, or 2 over t to the 1/2. There's lots of different ways you could write it. I'm going to put it back with a radical because it started with a radical. If you don't put it back with a radical, it's not wrong. So I don't want anybody to worry about that. Sometimes it's easier to work with radicals. Sometimes it's easier to work with fractional exponents. It just depends on what the rest of the question is. It's actually asking me, what is g of 4? I want to know what is g prime of 4, which is equal to 2 over. Now see, if I plug in 4, it's a lot easier to take the square root than 4 to the 1/2 power. So the square root of 4 is 2. That's 2 over 2, which equals 1. The answer to this, I believe, is 1.
I do have one question.
Yes.
Are you only able to plug in for question D, the 4 at the end once you have
Yes.
taken out all the terms?
Yes. Do you know why?
Because the same reason we factor.
No, well, not really. If I plugged in 4 first, then I would have 4 times the square root of 4, which is 4 times 2, which is 8. And then the derivative of 8 is 0, because the derivative of any constant is 0. If I plug in numbers before I take the derivative, I'm always going to get 0. Yes?
Yeah.
Okay, good. We have 2t cosine of 3t. And I'm going to make my line. And then what do you guys notice about this? I'm going to make you work a little bit.
All of the terms are attached.
Attached in what way?
They're all linked to the cosine, and you're going to have to, I guess, technically factor it to separate all of those pieces.
They're not linked. They're multiplied. I can put 2t squared cosine t, sine t, natural log of t. They're not linked. They're different functions multiplied together. On this formula sheet, do you see anything that looks like 2t cosine of 3t? I have a cosine function, and I also have a t function. T to a power. Even though T is only to the power of 1, it's still T to a power.
Mm,
So as you can see, I have two different functions multiplied together, which means I have to use the product rule. Here, let's do the problem. I have F times G. And that means if I want to take the derivative of that, now I'm going to say F equals and G equals. What should we make F equal to?
F could be equal to 2t.
Sure. Then what would F prime be?
A constant, so it would be 0.
It would not, because T is not a constant. 2 is.
The derivative, wouldn't it make it? Oh, would it be 1 then?
But would you have to multiply 2 with the cosine, or like the derivative of the cosine eventually?
Well, everything's multiplied together. So you have like 2 times 3 times 4, right? Does it matter if I multiply 2 times 3 first or 2 times 4 first? Like, do I have to multiply 2, then times 3, then times 4? Or can I multiply 2 times 4 times 3? Or can I multiply 3 times 2 times 4? Like, they're all the same, right?
Oh, right. So it's G, you would do 2 cosine, right?
No, because of you either put it with the T or you put it with the cosine. But if I had 2T times 2 cosine, I'd have 4T cosine, wouldn't I?
Then
Right.
could I do 6t squared or
No, don't, that 3 stays inside of the cosine for now.
okay.
Because that's part of the function. You wouldn't say that this, if I have F is equal to 2T, I want to know what the derivative of that is. I can take the 2 outside, right? Remember that rule?
Yeah.
So I can say this is 2 times the derivative of T. And what's the derivative of T?
One.
1, yeah,
One.
because it becomes power of 0, which
What am I going to make G?
Cosine of 3t.
Cosine of 3T. What would G prime be? Do you have the derivative sheet in front of you, or do you want me to
would it
pull
be
it?
negative sign? 3?
It would, well, you're very close. Yes. We're here. Cosine of omega t is so if omega is 1, then cosine of t is negative sign. But we have that omega. -3. -3 sine of 3t here.
Okay.
Yes?
Yeah.
Okay, good. So now I know F, I know F prime. I know G prime. I don't have to worry about the 2 because I put it into F, right?
Yeah.
So now I want the derivative of H of T. And that's equal to the product rule, which is F prime G plus G prime F, where we already said what everything is. I just plug it in. What's F prime?
2.
Just 2?
Good. And then what's G?
-3 sine 3t.
Nope, that's G prime.
Oh, just G?
It's G. See how it says F prime?
Oh, okay.
G,
That would just
G.
be cosine 3t.
Exactly, 2 cosine of 3t plus G prime, which is negative. So -3 sine of 3t times F, and F is 2t times 2t.
So is
Okay,
this rule just the
it's
old
just product.
term times the new term and then vice versa?
It's literally the derivative of one function times the other, plus the derivative of the other function times the first. I mean,
Okay,
it's just the formula. That's all you need to think about it as.
okay,
You don't have enough understanding of what we're doing to do much of anything but use the formulas. And I'm sorry to say that because I usually don't like teaching formulas. That's why I think practice is really important. Just make stuff up or go on to some website and find a worksheet that has answers. Don't look at the answers, do the worksheet and see if they're right.